Hello guys, so we meet after a long time and I hope that you are enjoying the course. Now today I am going to discuss assignment 1 and if time permits then assignment 2. Now I have set the assignment little difficult because I suppose that doing this kind of problems only you will get a better understanding of the theory or of the concepts which we have discussed during the lectures. So one by one I will now discuss the whole assignment 1. So the first problem was that mark the correct workflow for MEMS sensor, and for MEMS sensor what we know that the first, let us say for a MEMS force sensor it will be like an external force, and that external force will be applied on some or will act on some moving structure, and then because of that external force some deflection will happen, and then we will measure this deflection by some electronic or optical way, and then we can back calculate the applied force. So the correct option is C. So C is the correct option. Now next question is from scaling, that is the question is that what is critical length for a glass cube having density of 2500 kg per meter cube to float on a fluid having surface tension of 27.56 millinewton per meter. Now buoyancy will be neglected. Now this problem is almost similar or exactly similar, just the values are different from like the problem what we have discussed during the lecture. So but still we will do the solution. So we know that there are two different forces, right? One is the mg or the weight of the block which is acting downward, and then we have surface tension force which is gamma s, and that is acting upward, right? And we are neglecting buoyancy. Now at critical length where exactly these two forces will be similar, will be same, is when gamma s is equals to mg, right? And then we know that s equal to 4L. So because this is a block and similar to the our like the lecture problem, it is 4L, where L is the each side of the block, into mg. M is what? M is equal to density into volume. So density is rho and volume is L cube for a block, so into G, and then if we put all the things together, then we will get that L square is equals to 4 gamma divided by rho into G, right? Or L equal to square root of 4 gamma by rho G, and if we put gamma equals to 27.56, right? So here you have to be very careful with the units. Okay, so this is for 27.56 millinewton per meter. Now that means that it is 27.56 into 10 to the power minus 3 Newton per meter. So everything we are doing in SI unit. So accordingly we need to convert all the values also in one kind of unit. Then G equals to 9.8 into meter per second square, and rho is given as 2500 kg per meter cube. So if you put all these values, then we will get L equals to 2.12 millimeter. Now the next question is from mechanics, and what we are seeing here that there are two beams which are connected in parallel and a mass is connected to that, right? And we have the beam length as L, width as W, and depth as H. The beam material has an elasticity of E. What will be the equivalent spring constant for such a system? As the force acts thisward vertically downwards, right, then it is only axial stress, and for axial stress we know that for any single beam, what we have discussed during the lecture videos, that K equals to W H E by L. Now both the beams are same, so both the beams have same K value, right, and they are connected in parallel. So if they are connected in parallel, so it is like a parallel spring, right. So they are like two springs connected in parallel, and then let us say we are pulling it, this is fixed end. Now for this case we know that the equivalent spring constant K equivalent is equal to 2K, that also we discussed during the lectures, right. So here the correct option is 2WHE by L. Okay. So the next question is also related to scaling, or to give an idea of how the surface and volume relates. Okay. Now in this question you can see that there is a matchbox and each matchstick is 50 millimeter long and cross sectional area is 4 millimeter square. Now assume also that each matchstick need 1 millimeters of surface coating for ignition, means at the side of the in this side of the matchbox we need 1 millimeter square of coating for at least one matchstick. Now the matchbox size is 50 mm into 30 mm into 4 mm. So the question is there enough ignitional area for all the matchsticks it can enclose? So you can see that the right answer is yes, we have enough area, but let us calculate that. Volume of the box V equals to L into B into H, and that is equals to 50 into 30 into 4. That comes about 6000 millimeter cube. Volume of each stick, so this is volume of each the box. Now volume of each stick is equals to 50 into 4 millimeter square is the area. So 50 into 4, that is equals to 200 millimeter cube. Now it can enclose then number of sticks equals to 30, and we know that one particular stick need 1 millimeter square, right. So 30 stick needs 30 millimeter square of ignition area. Area equals to 30 into 1 equals to 30 millimeter square. Okay. Now how much can be the area of this side? So this side area is, this is 50 and 4, right. So the length is length L is 50, and the height is 4 millimeter. So the area available (50 into 4) equals to 200 millimeter square, which is greater than 30 millimeter square. So we have enough area to ignite all the sticks. Now this question is again related to scaling, and this is just simple mathematics what you need to do. So here we have given the frequency formula, that is frequency f is equal to 1 by 2 pi into square root of k by m, and that also you know from spring mass system that the natural frequency is 1 by 2 pi into square root of k by m, where k is the stiffness and m is the mass. Now here you see that I have mentioned that the effective mass. So what you need to understand is the actual mass and effective mass while vibration or lump mass while vibration is not same, because of the stiffness it also contribute to the inertia. So because of that the effective mass or lump mass while vibration and the actual mass of the system may not be same. But in that case we have already mentioned that the actual mass or the body mass and the effective mass is related just by a constant, so it does not matter. So we have mentioned that we will consider only transverse vibration. Transverse vibration means that the cantilever is like this, one side it is fixed and the other side I am just applying transverse force, right. So this is transverse vibration, and for transverse vibration we know that the stiffness constant, let us say call it Kt, is equals to 3 Yi or Ei, where Y is the Young's modulus, by L cube, where I is the area moment of inertia. We know that I equals to B H cube by 12. If we put that, then it becomes Kt equals to Y B H cube by 4 L cube. Now for the both the cases, like alpha and beta, one case it is only BHL, and another case we are multiplying with the scaling factor alpha and beta. So K1, where we are not multiplying anything, any scaling factor, there it will be Y B H cube by 4 L cube, and K2 where we are multiplying with a scaling factor, then beta becomes B becomes alpha B and H becomes beta H. So it will become alpha B into beta H whole cube divided by 4L cube. So K1 by K2 is equals to 1 by alpha beta cube. Now what is the ratio of the masses? So mass M1 by M2 is equals to rho into the volume. Volume is, in the first case it is L B H, and in the second case it is L alpha B to beta H. So it becomes 1 by alpha beta, right. So the F1 by F2 is equals to 1 by 2 pi will get cancelled, and then you will get K1 by K2 square root of K1 by K2 into M2 by M1, and that is equals to square root of 1 by alpha beta cube into alpha beta, and that gives you only 1 by beta, and beta was mentioned as 10 to the power minus 4. So 1 by beta is 10 to the power 4. So the correct option is 3. Now next question is very simple. Actually we have just asked to calculate the capacitance and force for two different cases, again just by changing the unit. from meter to micrometer. Now the objective of this question is to make you understand that you will see in the answer that while the force is same, the capacitance is different, but still the force is same, and that we will calculate now. So we know that C is equal to epsilon naught A by D. Let's say we are considering free space. So C equal to epsilon A by D, and force is equals to minus of d G. G means the gap of the energy stored in the capacitor, and that is equals to half C V square. Let's write it also as G. Okay. So if you calculate like C equal to again epsilon naught A by G, so you will get minus minus will get cancelled, so you will get half of epsilon naught A by G square and on top V square, right, that is the force. Now the point I would like to clarify here, see that the C for the capacitance, it is on in the numerator it is area, and in the denominator it is only a length scale, that is the gap. So the scaling effect, like changing the unit, will affect the capacitance. So if you put all those values like this area, gap and epsilon naught you already know, so then you will get that without scaling CWS equal to 8.85 into 10 to the power minus 14 farad. Okay. Whereas if you make it to meter to micrometer, then you will get C scaling is equals to 8.85 into 10 to the power minus 20. So the point here is that you see our 88.5 into 10 to the power minus 21. So the point here is once you calculate without scaling, then you don't need to calculate again the full for the scaling, because you know that you are changing just from meter to micrometer, and for that there will be an extra 10 to the power minus 6 at the numerator. So that is that came here, and that's why it becomes just 10 to the power minus 20. And if you put all those same epsilon naught A and G value whatever is given according to the question, then you will get that force without scaling is equals to 110.625 into 10 to the power minus 8 Newton, and with scaling you don't even need to calculate because it will be the same value. Right, because A and G both will get converted from meter to micrometer, so we don't need to calculate anything, and we directly get the answer. So this is question number 6 to 9. Now choose the incorrect option. So in that you know that 1 by rho is equal to m by EI, or 1 by rho is equal to the radius of curvature is equal to d to w dx square. These are all like correct expression, but the C is not a correct expression. So this is the answer. Now two statements are given. One is strain energy of a body is integration over half sigma epsilon. Sigma epsilon means your stress and strain, and another is Castigliano's theorem. And if you see the lecture videos, then both the options are correct, both the statements are correct. So this is C. Now question number 12, there we are giving a beam, polysilicon beam, which has a Young's modulus of 170 GPa, and length is 100 micron, width is 10 micron, and height is 15 micron. Now a proof mass of 50 microgram is attached to its free end, resulting in a guided beam kind of motion. So this is an important point, that the motion is already mentioned as guided, and acceleration is applied in y direction, it is let's say 12 meter per second square, and z direction it is 15 meter per second square. So if the spin constant for a guided beam is already given, and that also you have seen from our lecture videos, that it is 12 yi by L cube, then what will be the magnitude of deflection produced in y and z direction. So you are already saying that this is the correct option, but how do you calculate? So for that, just it is the same, like you just need to put the formulas, but you need to be careful about a few things. So what are those things? First of all, k equals to 12 yi by L cube. Now I is equal to bh cube by 12, right? Now for the y direction, I can directly put that, right, bh cube by 12. So it is k y is equal to 12 will get cancelled, then y bh cube by L cube. You know all the values. If you put those values, then you will get k equals to 5737.5 Newton per meter. So one thing you need to be careful, 170 GPa, y is equal to 170 GPa means 170 gigapascal, or 170 into 10 to the power 9 Newton per meter square. So all the units will be in meter or Newton or kg, like that, right? And BH and L, all the values are given in micrometer. So you have to convert it to meter by multiplying 10 to the power minus 6. So like that if you put, then you will get ky value. We have mentioned the acceleration and asked the deflection, right? Now what is the force? Force is equals to ky, and let's say the deflection is y. So ky into y, ultimately I need to calculate the y, and that is equals to m into a, means mass, like the proof mass into the acceleration, right? So proof mass is, so this is 50 micrograms, so I am 1 minute I will put that values, and into a is the let's say small a is the acceleration. Now small a in y direction is 12 meter per second square, but this m is equals to 50 microgram, and I have seen many of the students have done this mistake, that they have just converted it into gram. So this is 50 into 10 to the power minus 6 gram, but we need to convert it into kg because that is the SI unit, right? So 10 to the power minus 9 kg. These things are simple but important, because ultimately because of this unit conversion, your whole design will change. Now, so you know ky value, so y equals to, or the deflection equals to ma by ky. So m you know, a you know, and ky you have calculated. So if you put that, you will get 0.1 micrometer. Now for z direction also it is all same. Then why I gave this problem also for the z direction? Because you need to understand one particular concept here, that is ky, while the force is applying in this direction, it is perpendicular to the width and along the edge. So while I am using the I equal to bh cube by 12 expression, this is the area moment of inertia expression, I can use it directly. But if I apply the force in like z direction, then I am applying the force along its width, and h is actually perpendicular. So in that case, Iz is not bh cube by 12, rather h b cube by 12, and because of that kz will change, and kz, all the other terms are same, so it will be y h b cube by L cube, and that will be equals to 2550 Newton per meter. Okay, so but just by changing from y to z direction, the area moment of inertia changes, and because of that kz changes, and then you apply the again same area. Now the acceleration will be 15 meter per second square and mass is same only, right? So if you put all those values, then the deflection in z, let's assume that is z, will be equals to m into az by kz equals to 0.29 micrometer. So this is the correct answer. Now the next problem is also from mechanics and similar kind of problem, and you need to be careful about the points which I mentioned in the last problem also. Okay, so there are 6 beams you can see, and they are all connected to one side to the proof mass and another side is fixed. Now how these motions are, for all of these motions, you see last time we have mentioned, right, that this is guided beam, but here we have not mentioned, but it will be guided beam only, because there will be no slope in this end also at this end, right, and because of that this is the guided beam stiffness constant we know already, 12 yi by L cube, where I equal to bh cube by 12, and here you need to see that the out of the plane thickness is 2 micron, right, and in plane thickness is, in plane width is 8 micron, means this is 8 micron, in plane width is 8 micron, and out of the plane width is, out of the plane thickness is 2 micron. So in this case also, like the 8 micron is actually the thickness, because the proof mass is moving in this direction. Again let us say y, here also it will be like we write y equal to bh cube by 12, so 12 get cancelled, and then L cube but this, so along the force direction it is actually 8 micron. So now the h is actually 8 micron and b is actually 2 micrometer, right. So and L to already you know 150 micron, and y is also given as 169 GPa. If you put those values, then you will get the kg, but let's calculate the directly the equivalent, like the k equivalent. So k equivalent, how much it will be? See, all these beams are connected in parallel, right, because all of them have the same deflection. So k equivalent is equal to 6 kg, right, and we need to calculate ultimately the deflection, right, in y direction. So we know the proof mass, so 50 microgram mass, right, and 50 microgram mass means again m equals to 50 into 10 to the power minus 9 kg, right, it is not gram, it is kg. So if we then the deflection y will be m into g, g is 9.8 meter per second square divided by 6 kg. If you put all those values, then you will get, you can directly put here that m into g divided by 6 y bh cube, and on the top you can put as put the L cube, right, and then you will get, so here you know m, you know g equals to 9.8 meter per second square, you know L equal to 150 micron, you know y equal to 169 gigapascal or 169 into 10 to the power 9 Newton per meter square, you know b equal to 2 micron. So this is most important, that b equal to 2 micron and h is equal to 8 micron, not the other way, and if you put all those values, then you will get 1.59 micrometer. So, that is all for assignment 1.